Hello everyone, myself Harish Karnati. I am the Prime Minister Research Fellow at IIT Roorkee. Today I am going to deliver a discussion on just a minute. So many people are joining. We will wait for 5 more minutes and we can start the discussion. Yeah, I hope we can start this discussion. Yeah, myself Harish Karnati. Today I am going to discuss week 1 practice assignments of the previous year. It's a basic electrical circuits. The course code is E93. Just a minute, few more people are joining. Yeah. This is the first question for the circuit shown below. Find the average power absorbed by the 10 ohm resistor. It means this output 10 ohm resistor. What is the average power absorbed by this 10 ohm resistor? We have to find out. For that thing, here how many loops? Here this one is the one loop, and this is having a one node. First, this source is the source which is represented with this is called independent source. The source which is represented with some, this is called dependent source. I hope you people will clear with these independent sources and dependent sources. So I'm going with this thing, loop equations. First, apply the KVL in this first loop. The for applying KVL, this the voltage applied to the first loop is equal to the voltages across this 4 ohm resistor and across this dependent source, right? The voltage, the KVL equation is 8 at an angle of 20 degrees equal to the voltage across this 4 ohm resistor is the current flowing through this 4 ohm resistor is I naught amperes. What is the voltage across this 4 ohm resistor from the Ohm's law? V equal to I into R, right? Here R equal to 4 ohm, then I equal to I naught, that is equal to 4 I naught. The voltage drop equal to 4 I naught. And here the voltage drop across this dependent voltage source equal to 0.1 V naught. This is the first loop equation. I hope it is clear. This is the first loop equation. And going to the next loop, this we consider, let us suppose, a node A. Here this current direction is 8 I naught. This is a dependent current source which is having a pair of 8 I naught. What is the opposite direction of the current? One can represent this current as minus 8 I naught. Okay. So from the current divide rule, how can we write this? Let us suppose this current as a Ix. How can we write this Ix? Ix equal to what is let us suppose this current as IA. IA into opposite resistance. Opposite resistance, what is that opposite resistance? J5 ohm by total resistance, right? What is the total resistance? J5 ohm plus minus J5 ohm, this total resistance plus 10 ohm. What is the IA here? It is minus 8 I naught plus J5 ohm, right? J5 ohm minus J5 ohm plus 10 ohm, right? This J5 ohm minus J5 ohm cancel, and minus 8 I naught into J5 ohm by 10 ohm. What is this value of this thing? 5 ones are 5, 5 2, 2 4. That is minus 4 I naught. Okay. The Ix equal to minus 4 I naught. The current, sorry, the current flowing through this is minus 4 I naught. Okay. What is the voltage from the Ohm's law? V naught equal to I into R, right? What is the I here? It is minus 4 I naught into what is the R here? It is a 10 ohm. So that V naught equal to minus 40 I naught. I hope it is clear. This is equation number 2. Substitute this equation number 2 in equation 1. What is the equation 1 in what is the equation 1 in? Yes, sure. I hope this equation 1 is clear, right? I am rewriting this equation 1 in the next slide. It is 8 at an angle of 20 equal to 4 I naught plus 0.1 V naught. 8 at an angle of 20 equal to 4 I naught plus 0.1 V naught. This is equation 1. Yeah. Here I just applied a current divide rule. A current divide rule equal to, current divide rule is nothing but here a current I. Here there are two impedances which are connected in parallel. Let us suppose Z1 and Z2. The current flowing through this Z2 resistor can be defined as I equal to opposite total current into, sorry, IZ2 equal to total current I into opposite resistance, that is Z1, by total resistance, that is Z1 plus Z2. In this case, the total current I equal to, it is flowing in this direction. We want the current in this direction that equal to this, just opposite to this 8 I naught, right? That is minus 8 I naught. That I considered minus 8 I naught. What is the opposite impedance, that is Z1? Here the opposite impedance is J5 ohm. That is J5 ohm. What is the total resistance Z1 plus Z2? Here Z1 equal to J5, Z2 equal to this total, right? These two are connected in series. Therefore, total equal to minus J5 plus 10 ohm. That's what I written, my J5 minus J5 plus 10 ohm. By simplifying this thing, I got Ix equal to minus 4 I naught. From the Ohm's law, we can written V naught equal to this 10 ohm into this, the current flowing through this 10 ohm, right? That is minus 4 I naught. So V naught we can written as minus 4 I naught into 10 ohm, that equal to minus 40 I naught. It's clear, right? That V naught equal to minus 40 I naught. We are substituting this equation to, sorry, V naught equal to, yeah, I is missing, right? Here it is, so I naught equal to V naught by minus J40, that equal to, what is the value of 1 by minus J40? What is the value of 1 by minus J40? You can comment that, you can do with the calculator and you can comment, drop in the comment box. That equal to minus, sorry, plus 0.025 J into V. Is it clear? V naught. Just a minute. Okay, we can substitute these equations in equation 1. It is 8 at an angle of 20 degrees equal to 4 I naught plus 0.1 into, what is the V naught value? Minus J40 I naught, which is equal to 4 I naught minus 4 J I naught, 0.1 into 40, it is 4, right? So I naught equal to 8 at an angle 20 by 4 minus J4. It's clear, right? So we got the I naught, and we can put this value to get V naught. V naught equal to minus J40 into I naught, 8 at an angle 20 by 4 minus J4. What is this value of V naught? One can calculate and drop in comment box. It is approximately 56.56 at an angle of minus 25. So what he asked in the question is, what is the average power absorbed by the 10 ohm resistor, right? So the power absorbed, P absorbed equal to, what is the power absorbed by the resistor? This is V square by R, or it is I square into R. So P square, it is 56.5685 Rms square by R, it is 10 ohm. It is approximately 319 equal to 319.9 equal to 320 watts. Okay, if we have any questions, we can discuss the same problem in the end of these all problems. Coming to the next question, the next question is, for the network shown in the figure, assume that port impedance ZAB equal to R by square root of 1 plus omega square plus R square, sorry, omega square into R square into C square at an angle of minus tan inverse omega RC. He given as the impedance seen from the ZAB equal to R by square root of 1 plus omega square R square C square, angle of minus tan inverse omega RC. Okay. Find the average power consumed by the network. He asked average power consumed by the network, where R equal to 10 kilo ohm and C equal to 200 nanofarad and I equal to 33 sine of 377t plus 22 degrees. How it will be? It will be Im sine omega t plus or minus 5, right? Where Im is the maximum current. Im equal to maximum current, it is 33 amps. Omega is the angular frequency, it equal to 377 radian per second. And phi is the phase angle, it is 22 degrees. Okay. From these values, we will put these all values into the impedance equation ZAB equal to R, that is 10 kilo ohm 10k by square root of 1 plus 377 square omega square into R square, that is 10k square into C square. What is the C value? 200 nanofarads. 200 nano means 200 into 10 power minus 9 whole square at an angle of minus tan inverse omega 377 into 10k into 200 nanofarad. Nano. One can find out this Z value. What is this value? 377 square into 10k square into 200 nano. 200 into 10 power minus 9 nano means 200 nano square plus 1, right? It is approximately, this value is approximately 1.568 square root. 10k is also there. So what is the final value? 10k by square root of 1.568. It is approximately 7.985. 7.9859 k at an angle of minus tan inverse omega, that is 370. Omega, that is 377 into R, that is 10k into C, that is 200 nano. What is this value? 377 into 10k into 200 nanofarad. It is approximately 754 into 10 power minus 3. Okay. What is this tan inverse angle? This 7.9859 k at an angle of minus minus tan inverse of 754 into 10 power minus 3, that is 37 minus 37.015. Okay, this ZAB we can represent in a polar form as 7.9859K into cos phi, that is cos minus 37.015, plus I just represented in a polar form, that is Z at an angle of pi can be represented as Z, Z cos pi plus Z sin pi. This Z cos pi is resistance component and the Z sin pi is reactance component. So in the question he asked about active power. The responsible component for the active power is only the resistance component. So I'm interested about resistance component only. So 7.9859 into 10 cube into cos phi 37.015. This is approximately 6.3765 kilo ohm. What is the average power? Average power equal to Irms square into R, right? Here Irms equal to, the question he gave Im equal to 33 milliamps. Im equal to 33 milliamps. Irm is equal to Im by root 2, right? So 33 milliamps by root 2. 33 milli by root 2. What is the value 33 by root 2? It is approximately 23.33 milliamp. Okay, that P equal to 23.33 milli square into what is the R resistance component? The resistance component is 6.3765 kilo. 6.375 kilo equal to, what is this value? 23.33 into 10 power minus 3 whole square into 6.375 into 10 cube. What is this value? One can calculate and drop in a text box. It is approximately 3.469 watts. The answer for the question is 3.4 watt. Going to the third question. The third question given is find the average power absorbed by the 2 ohm resistor when the voltage waveform shown in the below figure. Okay, the voltage waveform is like this. So we want average power. The average power equal to P average equal to, what is this? Vrms square by R, right? Or else Irms square into R. In this question, he given voltage waveform. From this voltage waveform, we have to find out the RMS voltage. What is this RMS voltage? Vrms equal to square root of 1 by T integral of 0 to T V of T square into dt, right? Yeah, previous question, few people are commented like 3468.73 or 3.469 kilowatt. It's not in kilowatt. It's actually, it is 10 power minus 3 whole square, right? It will results into, okay, some simple calculations only. 23.33 whole square into 10 power minus 3 whole square means it's a 10. Sorry. It's a 10 power minus 6. And 6.375 into 10 power 3. You can multiply this thing. It will be 3.469 watt. You can recheck it, multiply and recheck it. Okay, coming to this problem, it is, what is the V of t here? V of t is the function of the voltage which is given in this figure. It is like from 0 to 2, it is some ramp. It is starts with 0 and end up with the 8, right? And from 2 to 5, it is 0. And 5 to 7, it is again same, and 7 to 10 it is 0. Like up to this point the waveform is repeating, right? Okay, the time period of this thing is 5 seconds. Why? Because from the 0 to 5 and 5 to 10 and 10 to 15 it is repeating. That's why the time period of this waveform is 5 seconds. And what about the function of this thing? From 0 to 2, it is RAM which is rising with the 4 times, right? It is, we can write 40 from 0 to 2. From 2 to 5, we can write 0. Okay, this is the function. So Vrms equal to 1 by T, that is 1 by 5. Integral 0 to, what is the 0 to 2 value? It is 4T whole square plus integral 2 to 5, it is 0 square into dt. Sorry, here also dt. It's clear, right? I am dividing this whole waveform into two parts. Up to 0 to 2 I consider one, and up 2 to 5 I consider other. So it is Vrms equal to 1 by 5 integral 0 to 2 4t square whole square. What is this value? 4 square into t square, right? It is 16 t square into dt. This 0 square equal to 0, right? So we take common 16 as a common. Therefore 16 by 5. What is this? T integration of t square? It is t cube by 3, right? It is lower limit is 0, upper limit is 2. Is it clear? So Vrms equal to square root of 16 by 5. What is the upper limit? It is 2 cube by 3 minus lower limit, it is 0 cube by 3. Right? This value is square root of 16 by 5. What is the 2 cube? 2 cube 8 by 3. That's 0 cube anyways 0. Okay. What is the power absorbed equal to? Vrms square by this across 2 ohms, right? Vrms square by 2 ohm. So Vrms square means Vrms equal to square root of 16 into 8 by 5 into 3. Vrms square equal to the square and root will be cancelled. 5 into 3 is 15 by 2, right? So 16 into 8 by 15 by 2. It is approximately 4.26. This is 4.2 watts. That's option A. A few people are already commented. It's good. Coming to the next question. Next question is, for the circuit shown below, find the input power factor. It means this is a source which is delivering power to two loads, which is of load 1 and load 2. Load 1 is having a 0.8 power factor and load 2 is having a 0.9 power factor. And load 1 is having a power of 20 kilowatt and load 2 is having a power of 16 kilowatt. So we have to find out the power factor seen from the source terminals. Okay, that P1 equal to the power delivered by the load 1, it is 20 kilowatt. Okay, and power factor 1 equal to 0.8 lagging. Similarly, P2 equal to power absorbed by the second load, it is of 16 kilowatt, and power factor 2 equal to 0.9 lagging. Okay, so what is the apparent power? Apparent power equal to active power P by power factor, right? This active power P equal to 20 kilowatt. What is the power factor? 0.8, right? I'm talking about S1. This is apparent power 1. So apparent power 1 equal to 20 by 0.8 kilowatt. What is the value of 20 by 0.8? It is 25. What is the units of apparent power? It is kVA. What's the phase angle? Equal to cos inverse of power factor 1. That is cos inverse of 0.8. So cos inverse of 0.8, cos inverse of 0.8, it is 36.86. Okay, therefore S1 can be written as 25 kilovolt ampere or volt ampere, whatever it may be, both are right only. 25 kVA at an angle of power factor. Already here he gave us a lagging power factor. Lagging means negative sign will come and 36.86 degrees. Okay. Similarly, for the load 2, that is S2 equal to P2 by power factor 2. Here P2 equal to 16 kilowatt and power factor 2 equal to 0.9. 0.9. 16 by 0.9 is 17.77 kVA. Here already active power in kilowatts. So we are representing apparent power is also in kilos, like kilovolt ampere. And coming to the phase angle, phi 2 equal to cos inverse of power factor 2, that is cos inverse of 0.9, which is of, what is the value of cos inverse 0.9? It is 25.84 and it is of lagging, so minus 25.84, it's good. Therefore S2 can be written as 17.77 at an angle of minus 25.84 kVA. Okay, total total apparent power delivered by the load equal to SL equal to S1 plus S2, right? The value of S1 equal to, already we calculated, it is of 25 at an angle of minus 36.86 degree, right? Here we already calculated, it is S1, it is of 25 at an angle of minus 36.86 kVA, and S2 just we calculated, this is 17.77 at an angle of minus 25.84. What is the sum of these two? 25 at an angle of minus 36.86 plus 17.77 at an angle of minus 25.84 kVA. What's this value? Which is equal to 42.5780 at an angle of minus 32.284 degree kVA. This is of S source at an angle of pi. Therefore, the power factors seen from the source side equal to, which is of cos of pi, right? That equal to cos of minus 32.284. For what's the value cos of minus 32.284? Cos 32.284 . What's the value of cos of 32.284? Which is of 0.845. Here negative sign is there, so this power factor is lagging. So which is of 0.845. Sorry, it's the option D, which is of 0.84 lagging. I hope this question is clear. Moving to the next question. Find the Z equivalent in the circuit shown below. Here they give the circuit. What is the Z equivalent from this seen from these 2 points? In this case, we represent some nodes like A and B. The same wire is connected here, right? So this is also point A. The same wire is connected from here, right? So this is also A. Same as this wire is also connected, it's like this is also A. So let us suppose we will name it is as Z1, Z2, Z3, Z4. We am right. I'm just redrawing that thing. This is of Z1, Z2, Z3, Z4. Okay. Z1 connected in between. This is my A point. This is my B point. Okay. Z1, this one, this resistor. Sorry, this impedance is connected between A and B, right? This is connected between A and B. Okay. And Z2 is connected between A and B. And Z3 is also connected between A and B. And Z4 is also connected in between this A point and this B point. So we want impedance across this AB points. So all the impedances are connected in parallel. So what is the equivalent impedance? 1 by Z total equal to 1 by Z1 plus 1 by Z2 plus 1 by Z3 plus 1 by Z4. Right? Okay, Z1 is 1 minus J 1 by Z total equal to 1 by 1 minus J1 Z1. Z2 is 1 plus J2 plus 1 by 1 plus J2. What about Z3? Z3 is J5. 1 by J5 plus what about Z4? It is 1 plus J3. 1 by 1 plus J3. Okay. What is this value of 1 by 1 by 1 minus J1? What is this value? 1 by 1 minus j1. 1 by 1 minus, that is 0.5 plus j 0.5. What about this value? 1 by 1 plus j2 value? 1 plus 2j, which is of 0.2 minus 0.4j. What is the 1 by 5j value? 1 by 5j, which is of minus 0.2j, plus what is the value of 1 by 1 plus 3j value? 1 by 1 plus 3j, which is of 0.1 minus j 0.3. Sum all the real components. This is 0.5 plus 0.2, it is a 0.7. 0.7 plus 0.1, it is a 0.8. And sum all the imaginary components, which is 0.5 minus 0.4, so it is 0.1j. Sorry, this is j. We will write here, it's better. J 0.5 minus j 0.4 minus j 0.2 minus j 0.3. What is the total? This is 5 minus 4, which is 1. 1 minus 2 minus 1 minus 1 minus 3, which is minus j 0.4. Right? This is value of 1 by z total. But we want z total. What is the z total? 1 by 0.8 minus j 0.4, which is of 1 by 0.8 minus 0.4 j, that equal to 1 plus 0.5 j. 1 plus 0.5 j, that is option 1. I hope this is clear. We are moving to next one. For the circuit shown in the figure, determine the value of V0 if Vin equal to 120 volts. The value of V0, sorry, yeah, the value of V0, where is the V0? V0 is here. The value of V0 when Vin equal to 120 volts. This Vin equal to 120 volts. How to find out this thing? First, consider this impedance as Z1 and this impedance as Z2. I mean, the impedance seen across these terminals is Z2. The impedance seen across these terminals is Z1. That equal to, these two are connected in series, right? This one and this one. What is the equivalent impedance? That is 30 plus J60 ohm. Why? Because these two are connected in series. So these are 30 plus J60 ohm. This 30 plus J60 ohm is connected in parallel with J30. That equal to Z1 equal to that J30 is connected in parallel with the 30 plus J60. What is the equivalent value? J30 into 30 plus J60 by J30 plus 30 plus J60. What's the value of Z1? 30J into 30 plus 60J by 30J plus 30 plus 60J, which is of 3 plus J21. This 3 plus J21 means the impedance across these terminals is 3 plus J. I'm just redrawing. Yeah. Across these points is Z1. So the Z1 is connected in series with 40 ohm, right? The Z1 is connected in series with 40 ohm. So the impedance across this point equal to, let us represent with the Z1 plus 40, that equal to 43, 40 plus 3, 43 plus J21. What about Z2? Z2 equal to J10 parallel with 43 plus J21. That Z2 equal to J10, sorry, J10 into 43 plus J21 by J10 plus 43 plus J21. What's this value? Which is 10J into 43 plus 21J by 10J plus 43 plus 21J, which is 1.53 plus 8.89 J. So here the voltage is 120 volts. What is the voltage here across these points? Let us suppose this V2. What is the voltage across this point? Similarly, like voltage divide rule only. What is the voltage divide rule? Voltage divide rule, V2 equal to total voltage, that is V in, into that resistance, that is Z2, by total resistance, that is whatever this resistance 20 ohm plus Z2, that is V2. That V2 equal to 120 into 20 ohm by 20 plus 1.53 plus 8.89 J. 120 into 20 by 20 plus 1.53 plus 8.89 J, which is of 2, no? Here it is not 20, it is 1.53 plus 8.89 J. Sorry for this. Z, here it is Z2, right? Z2 is 1.53 plus 8.89 J, that is 1.53 plus 8.89 J. So here 1.53 plus 8.89 J. What is this value? 46.5 57.472 at an angle of 57.79 volts. We know the value at this point, that is V2. We know the V2. What about the value at this point V1? We have impedance across this point, that is Z1. Same, we will again apply voltage divide rule, that is V1 equal to total voltage. In this case total voltage is V2. V2 into that resistance, that is here it is Z1 by Z1 plus this 40. Okay, that is 46.472 at an angle of 57.79 into Z1. What is the value of Z1 we calculated? Which is of 3 plus J21. 3 plus J21, 21, sorry, plus 40 plus 3 plus J21, which is of 20.6 at an angle of 113.63 degree. This is V1, this is not V2. So we know V1, we want this V0. Again voltage divide rule, that is V0 equal to V1 into J60. Yeah, V0 equal to V1 into the impedance, that is J60 by total impedance, that is 30 plus J60, right? The total impedance means this is the total impedance and this is the individual impedance. So 20.6 at an angle of 113.63 into J60 by 30 plus J60, which is equal to into 60J by 30 plus 60J, which is equal to 18.4257 at an angle of 140.20 volts. This is 18 point. The option C is the correct. Okay, here just a minute. Sorry, yeah, here he gave the value at this input terminals and he want at the output terminals. So yeah, here he gave value at this terminals and he want at this output terminals. So from we approach from voltage divide rule. The same problem one can solve with the nodal analysis also. They can consider this as a node 1 and this is as a node 2. Find out the equations for the node 1 and the equation for the node 2. Now you will get two equations. For node 1 you will get, sorry, node 2, that is v2, you will get one equation, and for v1 you will get one equation. By solving these two equations one can land up with a v2 and v1. And after getting this v1, again you have to apply a voltage divide rule, so you will get this v0. The same problem you can solve in a different manner also. Okay, sorry, thank you. That's for today's discussion. And if you have any queries in form solved solutions, you can drop a mail to this mail, harish_k@hre.iitr.ac.in. Yes, this lecture is already recorded and it's going to upload in YouTube as well. So all people will get that recorded video and recorded uh, written PPT also. Whatever we use that written document, this is also you will get in that NPTEL portal itself. Thank you everyone for staying for 1 hour of time. Thank you very much. Yeah, YouTube channel name, you can search with the subject name itself. The channel name is same as the subject name.